Welcome back. In today's class, we will learn about lists. List is the most frequently used data structure in Python. A list is used to create an ordered collection of items. A list can be created using an array of comma separated items or values within square brackets. So for example, list is equal to in square brackets item 1, item 2, item 3, item 4 creates a new list. The name of this list variable is lst, and item 1, item 2, item 3, and item 4 are the values that we want to store in this list. Lists are iterable, that is, we can use the in keyword to iterate through the elements of the list, and we can also store different types of elements within the same list. In C++, we saw vectors which were resizable arrays, wherein we could store elements of a given type. Now, lists are very close to vectors in C++. The two major differences are they don't store actual values, they store references to objects, and since they store references to objects, they can store different types of objects within the same container. We will go through different examples of creating new lists and manipulating lists in this class. So let's first begin by looking at some examples of creating new list. In line 13, I'm creating a new list of fruits. So the name of this variable is fruits. On the right hand side, again, within square brackets, we can write an array of comma separated values. The values are names of fruits. So apple, orange, banana, and pineapple are the fruits that we want to store in this list. Now when we print fruits, we should see these 4 elements. So before that, I need to switch the project. So let's go to lists, make it the starter project. And now when I execute this, I also need to change my Python environment. Now it should let us execute the program. Okay, now notice the list. When we print the list, it will simply print every element that is part of the list. So apple, orange, banana, and pineapple are the fruits that are stored in this variable called fruits. Now we can add new items to this list by using the plus equal to operator. The plus equal to operator is concatenating the list on the right hand side, and it was joining or merging it with the list on the left hand side. So our fruits list has currently apple, orange, banana, and pineapple. Now we want to add 2 more fruits, blueberry and blackberry. To do that, I'm creating a new list on the right hand side, and then I'm merging this list using the plus equal to operator. So now when we execute this line and print fruits, we should see fruits now has blueberry and blackberry. So it's simply merged to our initial list, and it just gets added to the end of the list. We can also use an inbuilt method called append. This is similar to push underscore back in vectors. The append method will simply push the new item to the end of the list or at the back. So now when I print fruits again by adding peach or appending peach, we should see peach to be appended to the list at the last position. Now we can also use this inbuilt method insert when we want to insert an item at a particular position. So suppose I want to insert kiwi at position 2 or index 2, then I can use this inbuilt method insert. The first parameter is the index of the position at which we want to add this new item, and the second parameter is the item that we want to add. So now when we execute this, I don't have a print statement right now. So let's stop the program, add a print statement here, and then let's continue and check what will be fruits. Now notice at the second position, since we added kiwi at the second position, inserted kiwi at the second position, now fruits of 2 is equal to kiwi. Okay. Next, let's see how to do indexing and slicing. We saw indexing and slicing with strings. The syntax is the same also with lists. Now notice lists are again defined as classes in Python. So when we declare a new list, in this example here, fruits is an instance or an object of the class list. So since it's an object or an instance of a class, we can use dot to call the inbuilt or the member functions of this class list. So append, insert are all member functions of the class list. Now to access a particular element of the list, we can use the square bracket operator and pass an index. So to access the first fruit, we can simply write fruits of 0. This should print apple. Similarly, we can use negative indices to access the last fruit, and this time it should print peach. Now I can use slicing to print all the fruits that are stored at index 5 up to index 7. So 5 and 6 should be displayed. So let's check that. Now at index 5 we had blueberry, at index 6 we had blackberry. So when we print fruits of 5:7, we see blueberry and blackberry. Now we can also use a step size with slicing. So the syntax for slicing is as follows. You have I, which is the start of the slice, j, which is the end of the slice. This is what we've been using so far. And then there is an optional k, which is the step. If we don't provide the k, then step size is 1. Here I want to show what happens when we use step size 2. So here start and end is not provided, which means the slice starts at the beginning and goes until the end of the list, and then every alternate element should be displayed. Now let's go back and check whether every alternate element is displayed. Notice the first element was apple, kiwi was the second element, pineapple was the fourth element, and blackberry was the sixth element. So every even element of our list can be displayed using slicing with step size 2. Similarly, if we use step size, different step sizes, we can jump with different steps to access elements in our list. Now we can use a list as a stack. So the append method lets us to push new elements to the end of the list, and similarly pop method lets us pop an element from the list. So here again a print is missing, so let's print fruits after the pop and check what happens when we call this method pop. Now notice the last element peach is removed. So when we pop, the element which is at the back is removed, and the list now contains every element except the last element. So we can use append and pop to create our own stack using the list data structure. Now there are few more inbuilt methods that are useful. So we can also use the inbuilt method remove to remove a specific item. So suppose we don't want to remove the last element always, we want to remove a specific element. For example, I want to remove kiwi. Then we can use the remove keyword, remove method. Now notice again there is a print missing, so let's add print. And this time our list of fruits will not contain kiwi. So the second element was kiwi, which is now missing. Now we can use slicing to replace multiple items in our list. So suppose I want to replace all the items starting from 4 and going up to 6. So 4 and 5 will be replaced using berries. So whatever is 4 and 5 right now, so 4, so 0, 1, 2, 3, 4. So 4 is blueberry, 5 is blackberry, and I want to replace both of them using a single item called berries. Now when we execute this line and print fruits, we should see the last item to be berries, and both blueberry and blackberry was replaced with this new item berries. So we can use slicing to replace multiple items in our list. Now we can use the in keyword to check whether an item is part of our list or not. So suppose I want to check whether banana is part of our fruits list, we can simply write banana in fruits. This should return a true if banana is part of our list and a false if it is not part of our list. So let's execute this line, and now notice since banana is part of our list, it prints a true. Similarly, we can use the index method. We saw the index method previously with strings, wherein we wanted to we saw the find method with strings. When we pass a substring to the find method, it returned a position at which this substring started in our original string. Similarly, the index method here will provide us an index at which this particular element is stored. So fruits.index will return the index at which banana is stored. So let's print the index. Notice banana was at index 2, so 0 is apple, 1 is orange, and 2 is banana. So banana is at index 2. These inbuilt methods will help us to make our programs simpler, so we don't have to actually implement all these trivial things. Python provides us helper functions that we can simply call to make our code simpler. Now we can also store items of different types in the same list, as I mentioned before. Now notice here I'm creating a new list on the right hand side, and this time the list has some characters and some items are integers. So even though we have items of different types, it's still part of the same list. So when I print different underscore objects, we will see all the items of this particular list, and it has a mix of characters and integers. So the way the items are stored again within a list is using references. So this particular character is of type string, so it's an object or an instance of string, and the list is simply storing the reference to this particular object. Similarly, the list is simply storing a reference to an integer 1. Since it's not storing the actual object and references, we can mix items of different types. If it was storing in C++, when we create vectors, we mention what is the item that we want to store, integer, float, or a double. And only since we are not storing references, we are storing actual objects or values. We cannot mix items of different types with vectors in C++. Now the syntax to create an empty string is as follows. Again, the variable name is even underscore integers. On the right hand side, simply we create an open and close square bracket, and this creates an empty list. In Python, all variables needs to be initialized. So if we want to create, if we want to store an array of items or values in a single variable, we can create an empty list and then add items one by one using the append function. So here in this small piece of code, I'm showing how to add all even integers beginning from 1 going up to 71. So all even integers between 1 and 70 will be added to this list even underscore integers using the append method. So first I'm checking whether I is divisible by 2. If it's divisible by 2, we will add it to the list. Okay, so let's simply print now this list of even integers. Now notice all the even integers from 1 to 71 is part of this list. Now we can use again the length method len, which we saw again in the previous class with strings, to query what is the number of items that are currently part of this list. So since we have all even integers between 1 and 71, the answer should be 36. So 36 is the number of items that is currently part of this list. Now, a more simpler way or more Pythonic way of creating this even underscore integer list is using what's known as the list comprehension. With list comprehension, we will use this syntax. So let's break down this syntax. First, on the right hand side, I'm creating a new list. A new list is created because I'm writing code which begins and ends with a square brackets. So within square brackets, I'm writing code which will fill the items that should be part of this list. So again, let's break down this syntax. So first we will write a loop in which we will loop a particular sequence or an element. Here I'm looping through an integer sequence. The range object will return as an integer sequence which begins at 1 and goes up to 70. Every integer between 1 and 70 will be part of this sequence, and the for loop will simply iterate through this integer sequence. Now the second part of this list comprehension syntax checks whether whether a particular integer is divisible by 2 or not. So if I is divisible by 2, then that particular value will be added to the list. So the syntax again here, this is the value that is being added to the list. So I is the integer value that is added to the list. It will be added only when I mod 2 is equal to 0. So only when this condition satisfies, an item is added. If the condition is not satisfied, then the for loop will simply go to the next iteration. So now when we execute this code and print even integers, notice again we should get the same integer sequence as before. All integers between 1 and 71 is part of this even underscore integers list. But so even though the syntax is pretty much the same, so we have a for loop, we have this condition, and now we don't use the append method. We are simply combining all three elements into a single statement wherein we have a for loop which goes from 1 to 71, and then we have an if condition which checks whether the current element of our loop is divisible by 2 or not. If it's divisible, we know it's an even integer, and if it's divisible, if the condition satisfies, that particular element is added to the list. We will see another example so that list comprehension is clear. We will be using list comprehension in the programs that we will follow in the future, so it's important to understand this syntax. Here I want to now use the even underscore integers list to check to extract all the perfect squares that is part of this particular list. So now notice I'm looping through the even underscore integers list using the syntax for num in even underscore integers. Since even underscore integers is of type list is an iterable, we can use the in operator to simply access individual elements of this list. Again, I have a condition, and the condition simply checks whether the current element is a perfect square or not. So num is the current element that we are iterating. So at the first iteration, num will be equal to 2 because 2 is the first element of our even underscore integers list, and we will check whether 2 is a perfect square or not. To do that, we will use the module math, and math will provide us some mathematical functions. Here I want to use the square root function and the floor function. So square root of number will give us square root of 2, and then floor of square root of 2 will give us the integer. So 1.41 is square root of 2 minus 1 is 0.41, and we're checking whether that is equal to 0. When we get a perfect square, for example 4, notice square root of 4 is 2, and floor of square root of 4 is again 2. So 2 minus 2 is equal to 0. So when we get a perfect square, this will evaluate to 0. And since we are checking whether this evaluates to 0 or this is equal to 0, only when this condition satisfies, we will add that specific element to our new list. So when num is equal to 2, this does not satisfy, so num will not be part of our squares list. When num is 3, again square root of 3 minus floor of square root of 3 is not equal to 0, so therefore 3 is not part of our list. But 4 is part of our list, as we saw. Similarly, let's try 9. Square root of 9 is 3. Again, square root of 9 is 3. Floor of 3 is still 3. 3 minus 3 is equal to 0. Since it satisfies this condition, 9 will be added to our final list. So now when we print squares, perfect squares, we should see 4, 16, 36 and 64 to be part of our final list. Notice 9 is not part of this list because 9 is not an even integer. 9 is an odd integer. So therefore it is not even part of the even integers list that we are iterating. Now it's not necessary to always have this if condition to create this list comprehension. Suppose I want to simply create all integers between 0 and 100. I can simply write this and print the integers. Now notice the syntax is exactly the same as before. We simply have a for loop to iterate through an iterable. The iterable is an integer sequence, and now we are simply adding every element that we iterate through. Here the syntax should be for num. Now when we print this integer list, it should print all the integers. Okay, notice integers between 0 to 100 is 0, 1, 2 until 99. So the if is optional. Suppose we want to add, we want to filter the elements that we want to add. We don't want to add all the elements that we are iterating through, then we can use the if condition.